previous videos, we have discussed the mechanism involved in substitution reaction. Now let us see how the mechanism will involve addition reactions. What, tell me? Addition reactions. Have you remember, children? Addition reaction where carbon-carbon multiple bond or carbon-oxygen multiple bond are converted into single bond. Here also addition may take place by electrophile, addition may take place by nucleophile. Let us move to the example, first example, like electrophilic addition reaction. Tell me, electrophilic addition reaction. One of the electrophilic addition reaction mechanism we have studied in first year. Related with what, tell me? When ethene, that is symmetrical alkene. Ethene, symmetrical alkene with electrophile H+. According to positive electromeric effect, reagent move to the carbon which takes up pi electron. It will produce CH2 plus and CH3. Same way, instead of symmetrical alkene, if I am going to take unsymmetrical alkene, CH3, CH, double bond CH2. Whenever the unsymmetrical alkene we are adding, let us take the example HBr, first year example, H plus Br minus. Movement of the pi electron can take place in two ways, either to this carbon atom or to this carbon atom. If it goes to this side carbon atom, it will produce primary carbocation. We will see both one by one. CH3, CH2, CH2B plus. This is what, tell me, which carbocation? Primary. Other, it will produce secondary carbocation. Have you remembered? As we said in the stability, tertiary carbocations are more stable than secondary than primary. Therefore, Br minus. Therefore, Br minus attack to the carbon. Which one? Secondary carbocation. CH3, CH plus CH3 gets attacked by what, tell me? Br minus. To get secondary carbocation converted to what, tell me? 2-bromopropane as the major product. But along with this, even will get 1-bromopropane. But 1-bromopropane is what, tell me? Minor product. 1-bromopropane is minor product. Actually, major and the minor product are decided on the basis of Markovnikov's rule. I will tell you what is Markovnikov's rule. Anybody can recall what is Markovnikov's rule? According to Markovnikov's rule, whenever the unsymmetrical alkene added with the reagent, added with what? Reagent. The negative part of the reagent means Br minus. Negative part of the reagent goes to the carbon containing less number of hydrogen atom, or positive part of the reagent, or we can say that positive part of the reagent goes to the carbon containing more number of hydrogen atom. Therefore, we can say that based upon this one, secondary carbocations are more stable than primary carbocation. Is it clear to you? And one more thing we need to remember, that instead of taking like a heterolytic fission where the cleavage of H plus and Br minus takes place, it may be homolytic also, but it is in presence of peroxide. We can use any peroxide, but usually preferred peroxide will be benzoyl peroxide. That time we can call it as anti-Markovnikov's rule. Before going to the example, I will tell you what is anti-Markovnikov's rule. exactly ulta. What we can say? According to anti-Markovnikov's rule, negative part of the reagent added to the carbon containing more number of hydrogen atoms. Anti-Markovnikov rule applicable only for HBr, but not for HI, HCl and HF. Why it is so? Question arises, why it is so? It is applicable only for HBr, I said. Why it is so? Why it is so for HI? Why it is not possible? Whenever the hydrogen iodide dissociate, it will form iodide free radical. And the two iodide free radical combine to form iodine molecule. It means that anti-Markovnikov's rule is not applicable for HI. It is not applicable for HCl and HF also. Why? They are having high bond dissociation enthalpy. Due to high bond dissociation enthalpy, they cannot produce the product based upon which one, tell me? Anti-Markovnikov's rule. Children, listen here. I will write one example where I will take one propene. Okay? I will write one propene in presence of peroxide. What happens? We will see. By remembering the anti-Markovnikov's rule, if I am going to write CH3, CH, double bond CH2 plus HBr. Whereas, in case of anti-Markovnikov's rule, whenever we are going to write with respect to what, tell me? HBr. When we are adding the anti-Markovnikov's rule in presence of C6H5CO taken twice O2. What it is, tell me? Benzoyl peroxide. Due to presence of benzoyl peroxide, free radicals are generated. Okay? Once they have asked in KC, which is the gas liberated during anti-Markovnikov's rule? Answer should be what, tell me? Carbon dioxide. Gas released is what? Carbon dioxide. So let us move to the major product will be CH3, CH2, CH2Br. 1-bromopropane is major product, whereas 2-bromopropane is what, tell me? Tell me? Minor product. Tell me what? Minor product. If same example, CH3, CH, double bond CH2, if I am going to add HCl in presence of benzoyl peroxide, tell me what will be the product? Product will be 1-chloropropane and 2-chloropropane. 1-chloropropane and what? 2-chloropropane. According to Markovnikov's rule, major product was 1-bromo. According to, whenever we are going for anti-Markovnikov's rule, we got 1-bromopropane as major product. But anti-Markovnikov's rule is not applicable for HCl, as I said earlier. Therefore, major product will be what? 2-chloropropane. Even though presence of peroxide, will get the major product as 2-chloropropane. Remember one thing, all these addition reaction takes place by the formation of carbocation. Formation of what, tell me? Carbocation. And according to the stability, tertiary, secondary and primary carbocation, this is the order of stability. Now let us see some of the example where during the reaction primary carbocation may be converted to secondary if it is possible over there by hydride shifting or methyl shifting. What it is, that we will see one by one. First let us see 1,2 hydride shifting. How come it is possible? 1,2 hydride shifting. We will take the example like Very important example. Like CH3, CCH3, H, CH, double bond CH2. 3-methyl but1-ene added with what? H plus. Electrophile. Any electrophile are going to be added. Movement of the pi electron to first carbon atom. Electrophile attacks over there. Will get CH3, CCH3. This H will be as it is. This carbon. Here we are going to get a carbocation as positive. CH3. Okay? Then this nature of carbocation is secondary. Possible that adjacent carbon atom containing two alkyl group, it can be converted into tertiary by shifting of hydrogen ion. It is called as 1,2 hydride shifting. What it is called as? Tell me. 1,2 hydride shifting, where we will get tertiary carbocation. CH2, CH3. Tertiary carbocation according to hyperconjugation, as we said in the previous videos in electronic effect. Tertiary carbocations are more stable. So therefore, Br minus can attack on tertiary carbocation to get the major product as 2-bromo, 2-methyl, what tell me? Parental chain? Butane. Correct. Same. In the same, this is example number 1. This example I have taken from previous question papers. Same way, another one more example is there in the previous question paper, where this carbon atom is containing 3-methyl group. Methyl group will be 3-alkyl. Okay? CH, double bond CH2. Instead of hydride shifting over here, methyl group is going to be shifted. This is called as 1,2 methyl shifting. It is called as 1,2 methyl shifting. So here what happened, tell me? By the attack of H plus, same way as I have written for earlier example, same thing we can write over here, that CH3, here, movement of the pi electron, attack of electrophile to the same carbon atom. What happened further? Just to go on practicing in the same way, what I have written on the board, CH plus, CH3. Methyl shifting takes place to get tertiary carbocation. CH3, CCH3 plus CH, CH3 and CH3. How nicely they are going to take place to get a more stable product. Okay? Every species want to become stable in their life, either by shifting or by transferring. CH, CH3 and CH3. Children, one assignment I will give it to you. Instead of methyl group, you take phenyl group. You practice it, it is called as 1,2 phenyl shifting. Finish? Now you may think that if I am going to take instead of hydrogen bromide, if we are going to take completely halide, that is halogen, dihalide. Okay, that example also we will see. Usually we will use bromine in carbon tetrachloride. Okay, these examples are very, very important. Practice all these examples and try to understand that stability of carbocation, we need to remember to go for mechanism. Not only carbocation, even free radical also, even carbanion also. CH3, CH, double bond CH, CH3. To this you add bromine. in presence of carbon tetrachloride. Do you know what it is? Cis 2-butene. Where we have studied cis? In geometrical isomerism, where molecules are lying on the same side, they are called as cis. We will get a meso compound. In the optical isomerism, as I said, even though they contain chiral carbon atom, but due to plane of symmetry, they are forming meso molecule. And if one will get a mixture of dextrorotatory and levorotatory both, because they are containing chiral center. So they may be dextrorotatory, they may be a chiral centers are representing by star mark. But if one is a dextrorotatory, other may be levorotatory, but they are optically inactive. That's why this mixture is called as meso compounds. They are called as meso compounds. Clear to you, children? Some more examples you need to practice by taking different examples. This is all about the electrophilic addition reaction. Now we'll move to last addition reaction, that is nucleophilic addition reaction. How does the nucleophile are going to be added? It is called as what? Tell me. Nucleophilic addition reaction. Nucleophilic addition reactions. What is nucleophilic addition reaction? Instead of electrophile, we are going to add a nucleophile. And this example can be decided on the basis of negative electromeric effect. Same example as I have written in the previous video, same example I am going over here. That is, whenever the aldehyde or ketone, this is aldehyde or ketone. What tell me? Aldehyde or ketone added with nucleophile. Nucleophiles are what? Negatively charged species or electron rich species. Movement of the pi electron towards more electronegative atom. So nucleophile goes to carbocation. They will produce addition product as. Even in case of ketone, RC or nucleophile O-. This nucleophile, addition of nucleophile may take place by adding hydrogen cyanide. Cyanide is nucleophile. This can take place by RMgX. What is RMgX? Grignard reagent. When nucleophile is R minus, MgX will get a positive charge. Even we are going to add nucleophile as ethoxide ion from alcohol. Even we can take by using, what tell me? Sodium hydrogen sulfide. But always remember that less hindered molecule will undergo addition reaction more readily. Repeat the sentence. What I said to you? Repeat the sentence. Less hindered molecule. This sentence is very important. Molecule undergoes addition reaction readily. Addition reaction readily. That's why usually we will see that whenever the molecule is less hindered, they are undergoing. Less hindered means what? A smaller molecule. A smaller molecule around carbonyl group will undergo more readily addition reaction rather than more hindered. What my sentence? All these examples, actually all these are second year examples. You may be remembering that hydrogen cyanide will produce cyanohydrinase addition product. Then RMgX, Grignard reagent, will produce primary alcohol, secondary alcohol and tertiary alcohol. Whereas the ethyl alcohol will produce what, tell me? Hemiacetal and acetal. This will produce white precipitate of respective bisulfite addition product. One thing you need to remember, that all these will produce addition product. But only the thing is that less hindered molecule will undergo what? More will be the less hindered will be the molecule, more easily will be the attack of nucleophile, more readily. Have you remembered in the one of the question paper they have asked related with what? Relate with one of the question paper they have asked the question. One of the question paper they have asked the question related with formaldehyde, acetaldehyde. They have asked like this question. Arrange them in the increasing order, where the formaldehyde will undergo more addition reaction, more readily addition reaction than acetaldehyde, than acetone. This was a question in one of the paper, that why it is so. We can write it as this will be less hindered as compared to this, as compared to this. So children, you need to remember that you cannot think only these three examples they are going to ask. They may ask the example in any of the way, in any of the molecule. Only this line you need to remember. Less hindered molecule, more will be the addition reaction will take place. Okay, this is all about addition reaction. The last one is what? Tell me. Elimination. Oh, this will wind up mechanism. We will go to elimination reaction. What is elimination? Addition and elimination are exactly opposite. How come it is possible? In case of addition reaction, what I said, multiple bounded molecule are converted into single bounded. So here, in case of this one, related with elimination reaction, singly bounded alkyl halide or alcohol are converted into alkene. Elimination reaction. Okay. Whenever the alkyl halide represented by what? Tell me. Rx, heated with alcoholic potash, alcoholic potassiumite. Okay, further, tell me, sodamite or alkoxide. All will produce only one product, that is what? Alkenes. We'll write one by one example over here. C2H5Cl. Always we'll practice, we'll get perfection for simplest example. Bromide, ethyl bromide, heated with alcoholic potash, we are going to get alkene. Which alkene will get? Tell me. C2H4, ethene, along with KBr, along with H2. But children, you know, alcoholic potash, elimination. That means that alkyl halide heated with alcoholic potash, they are going to produce what? Ethene. That is a colorless gas which is liberated. They have asked many times in paper that identify the colorless gas which is able to decolorize bromine water or Bayer's reagent. It is the ethene which is obtained from ethyl bromide heated with alcoholic potash. Same way, instead of alcoholic potash, even we can use potassiumite or sodamite, NaNH2. Potassiumite or sodamite. Another, as I said, the alkoxide. For this, we need to consider Williamson's reaction. Williamson's reaction. Actually, this reaction is called as what? Williamson's ether synthesis. Ether synthesis. In case of Williamson's ether synthesis, when alkyl halide heated with sodium alkoxide, we'll get the product as ether. but not all the time. Why? If alkyl halide is primary, what will be the product? Ether. If alkyl halide is secondary, what will be the product? Tell me. Ether plus alkenes. If alkyl halide is tertiary, what will be the product? Alkene. This reaction is called as substitution. Nucleophilic substitution reaction. Here substitution and elimination both will take place, but tertiary alkyl halide will undergo elimination reaction. Shall we go to one of the example? Yes. Let us take the example like CH3CH2, okay, with Br, ethyl bromide heated with sodium ethoxide. Heated with what? Tell me. Sodium ethoxide. Then product is what? Diethyl ether. Product is what? Tell me. Ether. What I said you just now? Alkyl halide should be primary. Instead of alkoxide, instead of this, even I can take, because as I said that alkoxide, OR minus, you can take tertiary butoxide, you can take any of the alkoxide, maybe primary, maybe secondary, maybe what? Tertiary. If I am going to take another example like tertiary alkyl halide. Tertiary alkyl halide. What is the name? Tell me. 2-bromo, 2-methyl propane with alkoxide. Alkoxide. Any alkoxide we can take, not necessary to take only sodium alkoxide. Any alkoxide. OR minus. Any alkoxide. The product will be alkene. Product will be what? Tell me. Alkene. This is isobutylene. Now you may think that why we are not getting ether? Because the nature of this alkyl halide is tertiary. That's why we are going to get the product as what? Isobutylene. If this may be primary, this may be secondary, this may be tertiary, no matter for us. Only alkyl halide should be tertiary, then only we are going to get alkene. If alkyl halide is primary, we are going to get ether. Correct? Same way if we are going for, same way, if the elimination reaction takes place, this reaction are also called as what? Elimination reaction. Dehydrohalogenation. Dehydrohalogenation. Here one more sentence you need to remember that. More hindered molecule. More hindered will be ease of elimination. Whatever the key point I am going to give it to you, that you need to remember. Ease of elimination. More hindered, ease of elimination. Less hindered, ease of addition. Finished? The last example is related with dehydration of alcohol. Dehydration of alcohols. OH group linked to open chain hydrocarbon, they are called as alcohol, as we know very well. Alcohols heated with concentrated sulfuric acid at high temperature, around 170 degrees Celsius. Dehydration takes place to get alkene along with the water. Okay, that's why it is called as a dehydration reaction. It is also related with alkene. This is also related with elimination reaction. Maybe elimination, maybe addition reaction. More stable carbocation has to be preferred. This completes the mechanism of organic reactions. Thank you.